Okay, let's take a look at the quiz. Okay, so here's the quiz. Let's go to question 1. It says use the method of Lagrange multipliers to find the maximum minimum values of f of xy equal x squared plus y squared, subject to the constraint x minus 1 squared plus 4y squared equals 4. So to use Lagrange multipliers, what do we need to find? So what's necessary to find to use Lagrange multipliers? Yeah, we need to find, but I'm going to say gradients because we have the function to optimize, and we also have the constraint equation. So we find the gradient of each of those two functions. So let's find first grad f. And grad f is, it's an easy one, or pretty easy. Hope it's easy for everyone. Yeah, 2x comma 2y. And then we find grad g, a little harder, but not hard. Nothing too fancy. So grad g. And what is grad g? Okay, so we're going to have, I'm going to write it as 2 times parenthesis x minus 1 for 2 reasons, actually. And then comma 2 times 4y, 2 times 4y. Okay, so there's 2 reasons. One, to kind of show that the chain rule kind of happened. And the other is that way grad f and grad g have something in common. Okay, what do they have in common? Yeah, they all have this multiplied by 2, which is good because we're going to be able to divide by 2 and it'll simplify things. So now we use the Lagrange multiplier theorem that says that the gradient of f is equal to lambda times the gradient of g for some constant lambda. And the solution to that will give us where there are extrema. So because we need lambda, I need to get into the equation mode. So what we can now say is that 2x comma 2y is equal to, and then it's going to be lambda times, and that was 2 times x minus 1, oops, x minus 1, comma 2 times 4y. Any questions so far? Okay, so now we can get the equations, and then I'm gonna just realize that because I planned this ahead of time, is that I could divide this whole thing by 2. And everywhere you see a 2, all the 2's are gone. So what we can say now is so that tells us x is equal to lambda times parenthesis x minus 1. And we also know that y is equal to lambda times 4y. Okay, but then we also have the constraint equation. And the constraint equation was, where is it? X minus 1 squared and then plus 4y squared equals 4. Any questions on arriving at these three equations? Any questions on this? Okay, so now we can solve them. Which is the easiest of the three that's going to give us some simple information quickly?
Y.
X.
Okay. The second one, the one with the y's in it. Okay, because when you have y equals lambda times 4y, if we just divide, for example, by 4y, you get lambda as a fourth. That gives us lambda right away. So that tells us lambda equals 1/4, just from the second equation. Is that clear? Okay, so once you know lambda is a fourth, now you just plug it in. And let's plug that in the first equation, and we can say x is equal to 1/4 times x minus 1. Any questions on that? Okay, let's multiply by 4 to get rid of the fraction. You get 4x equals x minus 1. And then let's just subtract x and divide by 3, and you get x equals -1/3. Any questions at all on how I just got x? Okay, we want y, so what equation haven't we used yet?
The third one.
Yeah, we haven't used the third one, so I'll just plug in, and let's do that. And I'm going to do a little in my head. -1/3 minus 1 is -4/3. -4/3 squared is 16/9. So 16/9, in fact, I better write this out, make it a little prettier. 16/9. And then we had plus 4y squared. Was equal to 4. Okay, and I could take that and divide by 4 just to get rid of the 4s. It'll be prettier. So we can say 4/9. Except it doesn't like fractions. 4/9 plus y squared equals 1. Some basic algebra. And then we just finish it off. We subtract 4/9. 1 minus 4/9 is 5/9. And take a square root of both sides. You get the square root of 5/3, plus or minus. So let's write that out. So y equals plus or minus one of these. I think it's basic. There it is. Plus or minus the square root of 5. Whoops, forgot the square root. Square root of 5/3. So that means our critical points are at, again, x was equal to -1/3. So we get -1/3, comma, that was the square root of 5/3. And then our second one, I'm just going to copy and paste this guy. And then we have a negative root 5 over 3. Any questions at all on problem 1? Any questions?
So I just want to be clear, since it's x squared and plus y squared, we only have a maximum, correct? There's no minimum?
Yeah, so in this case, technically, I didn't quite finish, but you look at this and we know that it's either going to be a max or min, right? So then you go and you go to the original equation and we say we have f of xy equals x squared plus y squared. So notice that yeah, the best thing to do, I think, in this case is check it. Okay. First thing, the plus or minus for y, that means nothing when it comes to f. Do you agree? Whether y is positive or negative, it doesn't change the function in terms of the value of f because we're squaring. And the square kills the negative. Is that clear? Okay, so that's the first thing, is to know that, so then you don't have to worry about the whole plus or minus thing. Okay, so then if you want to, and I guess to find the max or min, what we can do is you can just take any other point that works. For example, x equals 0, x equals 1, y equals 1. Do you see that that's on this constraint? Because if x is 1, you get 0 for the first term. If y is 1, you get 4 for the second term, and 0 plus 4 is 4. And if I plug in 1, comma 1, I get 2. 1 plus 1 is 2. Is that clear? So what we have is now you could just plug in negative a third, comma root 5 over 3. And see what you get. And notice if you do that, you get a ninth plus 25 over 9. Sorry, 5 over 9. Is that clear? So you get a ninth plus 5 over 9. And 1/9 plus 5 over 9 is 6 over 9. And 6 over 9 is less than 2. So that means it must have been a minimum. So the minimum is f of 1/3, comma root 5 over 3, which again is a ninth plus 5/9, which is 6/9 or 2/3. And that's the minimum.
Yeah, so I totally forgot to check to see if another point, any other generic point satisfies the constraint. So I labeled the 6/9 as a max instead of a minimum.
Yeah, I probably wouldn't take off points because I didn't say, technically I didn't say is it a max or min? Had I done that, then I could take off points. Does that make sense?
Yeah.
Because technically the question didn't ask you to determine if it's a max or min. It just says find the value. So I probably wouldn't take off points for that. But the value is 2/3. Because if you plug in, you get 2/3. Does that make sense? But it's really easy to tell if it's a max or min because all you do is try another point. And if you're smaller than that other point, it must have been a minimum. If you're bigger than another point, it must have been a maximum.
Do you recommend just checking the constraint every time, just in case?
It's always a good idea, especially in the real world. Because in the real world, if you thought you had a maximum and it was a minimum, and you make a decision based on that, you're actually making the very worst decision possible. Does that make sense?
Definitely.
So if you think you have maximum profit and you go with the strategy and it turns out to be minimum profit, you're fired. Or if you own the company, you're out of business. Does that make sense?
Yep.
Yeah. So in the real world, it's really, really important. This isn't the real world. This is math. Okay, but it is used in the real world. Okay, any other questions on question 1? Okay, let's go to question 2. And question 2 is consider the function f of x, y, z equals xy plus yz plus 4x, subject to the constraints x squared plus yz squared plus 4 equals 4, and x squared yz equals 9. Write out a system of 5 equations and 5 unknowns that, when solved, will find the global extrema of f of x, y, z. You do not need to solve the system. And I should have said, don't even think about solving the system. Good luck, okay? Because it's not a nice one. I didn't make it nice, okay? In the real world, if you have to solve the system, then you go ahead and use a computer, okay? But we could do this. So what we're going to do is we're going to use the big theorem of Lagrange multipliers. And that says that the gradient of f equals lambda times the gradient of the first constraint plus mu times the gradient of the second constraint. Any questions on that? Okay, so what we need to do now is we need to find these gradients, and we need to, set the equation set up. So let's do it. And what we can say is the gradient of f is going to be, let's see, y plus 4. I need to put in vector notation, y plus 4, comma, x plus z, comma, y. And that is supposed to be lambda times the gradient of g, and the gradient of g was 2x comma z squared comma 2yz. And then plus mu times the gradient of, let's call it h. And the gradient of h is 2xyz, comma, x squared z, comma, x squared y. Any questions on the Lagrange multiplier theorem and how it was able to get this equation, this vector equation? Any questions on that? Okay, so now we need 5 equations and 5 unknowns. So clearly the unknowns, hopefully it's clear to you, x, y, z, lambda, and mu are the unknowns. That's 5 unknowns. So we need equations out of this. So what we do is we take this vector equation and we're going to make it 3 separate equations. The first one will be a y plus 4. So it'll be the y plus 4 equals the lambda times 2x plus a mu times 2xyz. So let's write that out. And I'm going to do this because then I can see it. And the idea is I'm just going to write y plus 4 is equal to lambda times z times 2x plus mu times 2xyz. Any questions on the first equation? Okay, let's save that one and let's go to the second equation. So the second equation, we're going to do the same idea, except it's the second term of the vector, second component of the vector. So I'm going to just copy and paste, and that way I can have it all there for me. And we get x plus c is equal to lambda times z squared plus mu times x squared z. Okay. And then the next equation. Let's do the third equation. And the third equation will be y equals lambda times 2yz, or let's just write that as 2 lambda yz. You guys put the number first. And then plus mu times x squared y. And there's my third equation. How do I get the other two equations? The hint is they're the easiest ones.
They're the given equations.
Yeah, they're the given equations. And in fact, one of the nice things about, the quiz is if this works, I can just copy and paste them. That way I have to retype it. And then similarly, let's copy the next one. Okay, and I have 5 equations, 5 unknowns. Okay, you see why I told you don't even think about solving? Would you want to solve these guys in your 20-minute quiz? I don't think so. Okay, any questions at all on this quiz?
Yeah, well, we have a problem like that on the exam.
We won't have this exact problem, but anything you've seen in class is fair game.
No, but I mean like one of this complexity in terms and actually having to solve the system of equations.
Well, you have to solve it. Oh no, I would never make you solve something this horrible.
Okay, cool.
But could I ask you to set it up? I could do that. Because I don't feel guilty about this problem, telling you that you do not need to solve the system. Does that make sense? Because it doesn't really take that long. The longest part about this, I think, is typing. Do you agree? Okay, maybe you took the time taking derivatives, but I think typing takes a long time for this one. Okay, yeah, but I would never make you solve five equations, 5 unknowns that aren't even linear. Are you kidding? Okay, I wouldn't ever make you do that on homework by hand either. Okay, fully, that's this complex. Okay, but in your job someday, you may have to do it using a computer. Okay,
Larry?
Nikki. Yeah.
How did you decide which one was lambda and which one was mu for the gradients?
Oh, it makes no difference.
Okay, so you just set the gradient of 1 for mu and then the gradient of 1 for lambda?
Yeah, I did it in order at which they were given, because lambda comes before mu in the alphabet.
Okay, thank you.
But that's it. Yeah, no, because remember that what this is all about, never lose track of the purpose of this. What this is all about is finding the values of x, y, z that give you the max or min. Does that make sense? And
Yeah.
lambda and mu are middle steps. So it really doesn't matter which one you call lambda and which one you call mu, because in the end, you don't care. Okay. On the other hand, you can't switch around x's, y's, and z's. Okay. You can't just change those letters because those are actually fixed. But lambda and mu are just, placeholders, I guess, might you want to call them. Any questions at all on that? Okay, so are you ready to talk about the exam? Because that's what's coming up. So let's pop in, let's start with the syllabus. And let me remind you that we're in week 6. There is an exam on the 15th of May, that is this Friday. And it covers everything we've done so far. Because what we're doing today is reviewing for the exam, and yeah, the exam covers what we reviewed for the exam. And you've already had the homework, you'll have already had the homework due on Lagrange multipliers. So everything that we've done from parametric equations, that was our first topic, all the way through Lagrange multipliers is on this exam. Any questions on that? Okay, so it's a pretty large amount of material to be on an exam. That has a lot to do with the fact that none of us knew what was going on the day before class started. You know, I was hoping that we'd get back to class, and that's why I decided to delay it a little bit. And also I figured it might take you guys a little while to figure out the whole online environment and Proctorio and all that. So that's the reason why I waited a little longer than I usually wait for this exam. So if you don't like it, I apologize. I'm just doing my best trying to figure out how to work this out as well as I can. I didn't want to throw a test at you when you're still figuring out the system. But hopefully now that it's the 6th week of class, you've got this system figured out, okay? And I'm here to help you out in case you don't. So that's one thing. In terms of the exam must be taken using Proctorio. And if you remember, I think it was 2 weeks ago, maybe something like that, maybe 3 weeks ago, we had our practice Proctorio quiz. So it's that same system, and whether you like it or not, it's all I've got, and that's how you're going to be using it, okay? So you're going to have a computer with a webcam, and if it worked before, it should work again. If it didn't work before, it won't work again. And if it doesn't, so don't just like hope, you know, that it's going to work this time, because, and if it didn't work last time. Okay, so remember, you need to make sure your computer works. If for some reason your computer died between then and now, you need to get yourself a computer. The college still has computers left, but you have to do that right away, since there's only, you know, 2 days left, and Friday's too late, by the way, because the college is not open at 8:30 on Friday. Okay, so that's just a note, is that it will be done using Proctorio. And honestly, what I will do is if there's anything that looks a little fishy on your exam, then I go look at the video. Okay, if everything you do is just like you normally do it, and you know it's clear that you know you didn't go, you know, talk to someone else about it during the exam or that kind of stuff. If you made the same strange mistake that someone else made, then I'm going to look at the video. Does that make sense? So don't talk to other people on the exam. Okay, I do want to tell you what the very first question of the exam is. I think I'll type it.
Oh my God. Are you going to say true or false, Larry?
Nope. Question 1. This is an all or nothing question. You either get 100% or you get 0%, period. And you all better get, and not only that, if you get 0% on the first question, then I give you 0% on the whole exam. So you ready to hear it?
I guess so.
I have the exam on my other computer. Here, I'll show you. I don't know if you can see it. Okay. I scrolled up so you can't see the questions. So if I turn my head, that means I'm looking at the other computer, so I can type in exactly what it says. So here's question 1. Right, your name below. If you agree, not communicate with any adult and not use any other devices or materials for this exam that have not already been allowed by your instructor. Okay, so that's question 1.
How many points is this question worth?
1. Or all. It's either 1 or all. If you get it right, it's only worth 1 point. If you get it wrong, it's worth 100% of your test and you get a 0. So, but if you don't know how to write your name,
Yikes.
then you have a problem. Do you agree? That's a whole different issue. And again, if you're not okay being honest, then I'm not going to give you any credit. Okay, you need to not communicate with other adults. Okay, throughout the entire exam, and you're not allowed to use any devices or materials on the exam while you're taking the exam. Okay, that's not unreasonable, is it? Okay, it's no different than an in-class exam. If I see you talk to someone in the middle of the exam, then I would just take it away and rip it up, right? Okay, if you just started talking, how do you do number 3 or something, then that wouldn't be okay. So basically, this is an honesty statement. That's all it is. Okay, it's not a trick question, by the way, but it's just to make sure that you understand that you need to be honest. Okay.
I'm sure you've answered this already. I said I'm sure you've answered this already, but are we allowed to have like a couple pieces of scratch paper?
Okay.
Sometimes it's hard
Okay,
for
so
me
let me
to.
tell you what you're allowed. So this is the expressly allowed by instructor. You are allowed pencil or pen. That is always okay. You're allowed to come in with blank paper. Got it? So you're allowed to take as many pieces of blank paper as you want to bring in. You're not allowed to bring full notes or anything like that, but you can bring blank paper. Does that sound fair?
So do we just show you the blank paper before we start? Like, do we hold it up so Proctorio can see?
Yeah, the web, it's going to say, move your computer, move your camera around so you can see everything in your desk and around. And that's the first thing that Proctorio does. It asks you to show the room, and that's what it's going to show. You're going to show that paper. Okay.
Are we allowed to listen to music on the exam?
I don't know. Proctorio may zap you if you listen to music, because then it can't hear around. You're not really supposed to listen to music. Again, this is actually my second time using Proctorio, because I used it for my stats class 2 weeks ago for their test. But no one even asked about music. So I think that's because it was the first time they've had me as an instructor, whereas this is your second time from I think all of you actually. So I don't think Proctorio allows it. So that's the problem with it, because then it can't hear if you're talking and stuff like that. So sorry, like I said, I'm doing my best to try and, make this work for everyone. Any questions on question 1? Again, this is not a trick question, by the way. You type your name, that's all you have to do, but it's an honesty statement. Okay. Any questions on question 1? Okay, let me move to the last question. And you already know what the last question is. Tell me what it is.
Lagrange multipliers?
True or false?
No. Come on, you've all had me as an instructor. In fact, a few of you had me more than once.
It's going to be something we like about the class, or what you could do to change it.
Exactly. I do that on every test, including this one. And I'm not going to type that out because you've already seen that one. Whereas question 1, I've never given this question to a calculus class before because I've never done Proctorio. I've always been there in the room with y'all. But the last question is the same. And that is, state something that I'll even read it. Write down one thing that your instructor can do to make the class better, and one thing you feel that the instructor should continue doing. Okay. What I recommend doing, by the way, start with question 1, because you got to do question 1, and then move to the bottom and do question 13, because those are easy points. Okay. Okay, don't think for 10 minutes on it. You can think that ahead of time. You know exactly what you want to write. Any questions on that? And I got some bad news for you. So, and that is next quarter, for those who are taking any classes, just about any classes, I think we're all online. That they made the announcement
Yeah.
Friday. And not only that, for those who are transferring, it's not any better for you either. You know why? Anyone read the news about Cal State universities?
They're all still online.
They're all going to be online in the fall. They made that announcement.
Officially, they said that?
Yeah, that was yesterday's news.
Is that for Cal State or for UCs?
Cal State's.
Okay.
That doesn't, but I don't want you to get too excited.
Yeah.
Does not mean UCs are not online.
Yeah, they'll probably end up doing the same thing. But
Yeah, Cal State's have made they made the announcement yesterday. UC's, it's just a matter of time they're gonna make the announcement. I'm pretty sure. I don't see it being much different. So it's not just our college. It's pretty much at least all of California. I don't really keep track of out of state colleges. I don't know what UNR does, and that there might be some hope for them. But just let you know that that's going to happen. And I just found out they switched my schedule. Whether you like it or not, this might be good news, might be bad news, is you're going to have me next quarter. It was going to be Bruce, and then they switched it. Without even asking me, it just happened. Yeah, I told them I'll teach whatever. That's how I always am. So I'm going to be teaching Math 202.
Are you excited?
Yeah, I mean, what I told him is I think it's actually better for you guys to switch back and forth between me and Bruce. You don't get tired of us. But I don't have any say in anything. So I'm okay working with you, but I think it's good to get different types of styles. Okay, that's how it usually is in the university. I almost never had the same professor twice. Okay, except for higher level stuff. And when I'm saying higher level, I mean senior level courses. That's just a note. Sorry, but the other thing, which is a note, is really important, is think carefully about what you write for the extra credit problem, because I might listen to you. And be careful if you ask for something and then you get it and then you hate it. Just let you know that. Because we're talking about probably online next quarter also, which means that, again, this is my first time ever doing calculus online. And looks like my second time will be next quarter in the 202 class. So if you have suggestions, I'll take them. If you say, you should give everybody an A, whether they work hard or not, I'll still give you the points for extra credit, but no, I won't go with that one. So again, be constructive, think about, what's best for the class. That's what matters. Okay, any questions on that piece of the exam? Okay, the next piece, actually, I want to ask you all, and I'm okay actually making changes. I've written the exam, I actually took the exam, but it might be a little long, so let me tell you something. Not counting the first question and the extra credit question, because those should be, 10-second questions or maybe 1 minute, because the extra credit might be some typing. Special one, number one is typing your name. That should not take long. There are 11 questions on the exam. That might be a little bit long.
How many parts do the questions have?
Not a lot. So for example, the true falses are separated as 2 questions. Okay? So it's a little different than my regular style, and that's because it's through Canvas. It works a little better, I think, if there aren't a lot of parts. Otherwise, you're going to have to scroll up and down all the time. Does that make sense? So there aren't a lot of parts, but I would be okay if you want it to be a little shorter, and I'll take a problem or 2 out. But then, of course, remember, if it's shorter and one problem you can't do, you can't get an A on the test. Does that make sense?
What's our time limit for the exam?
So, right now it is, I think, an hour and 45 minutes. So it's from 8:30 till 10:15, I think is what I've got it set at. I could even make that a little longer, but again, I don't want to kill you either. You know, again, I'm just winging this. Normally, that's what it would be for regular class. Just let you know, unlike the quizzes and the regular class schedule, what we usually do, there is no webinar on Friday. So there's no Zoom part of this. You're just going to go right to the test. And in fact, don't go to Zoom, because what I've found, especially on the statistics test that I gave with Proctorio, is that Zoom is a complete memory suck. And for a lot of computers, they can't handle Zoom and then open up the Proctorio test. So don't even go into Zoom. Does that make sense? So I'll be checking my email at the beginning. I think it's better for me not to even encourage you to go to Zoom, because you may have technical problems if you do that. But before the test, I'll be looking at email in case you have questions. Sound good? So it starts at 8:30, not 8:35. Just let you know that. Okay, does that make sense? So do you want it to be shorter, or do you want it to be that number of problems? I can get rid of a problem. It's not that hard. I just delete the problem.
Is there any way to keep the number of problems but maybe just have like more time for the exam, or is that not possible?
I could
Yeah,
do
I'd
that, but I
prefer more
want it,
time.
but I need it to be unanimous to do that.
Yeah, I would like some more time, just because like, I mean, the quizzes are 20 minutes and those are usually only like 2 problems, and I still like need like every minute. So I'm just worried that there's not going to be enough time.
Yeah, no, I totally understand that. But I need you to vote. I need you to all vote yes. Do you see what I mean? Because anyone could veto extending outside of a regular time frame. That's
Right.
how the rules work in the college. So again, I don't like to break college rules. But if there's anyone that doesn't want it, then I will make it a, you know. So speak now. If you don't want it, say no. Okay, so I'm seeing all yeses, but I'm looking, because again, I could do it. I'm up for that. Okay, it does mean that it's going to be longer before you get to go to the bathroom, just warn you.
That's fine.
So don't drink a whole lot of water at the very beginning. And just before the test, what should you all do?
Use the bathroom.
Exactly, use the bathroom, because it's a long time. And Proctorio is not going to let you leave. Got it? Puts a big red flag if you go away. Okay, so that's a big note about restroom issues. Okay, just the way it is. Okay, a little different. Like I said, there's differences between in-class tests and a Proctorio test, and I'm doing my best. That's all I can tell you. Okay, so 2 hours, how's that?
Yeah, that'd be great.
Okay, so let's make it an 8:30 to 10:30 test. Okay, and again, I'm not going to be like sitting there doing anything. I might even take a walk or something, because you don't need me for the test. And in fact, you're not even allowed to email me, because once you're in Proctorio, you have to stay on the test. You can't change your screen. It locks it, supposedly. Does that make sense? Okay, so we can do that. So I'll keep it the same length, but make it 2 hours. I want to mention some other things. These are technical issues, but they're important technical issues. Everything has to be done in Canvas. It's not one that you're going to be able to email me anything afterwards. Does that make sense? So you need to type. Okay, I do not grade on how beautiful your typing is. So if you type in, I don't know, GRAD, I'm okay with that. If you type in, I don't know, even PARTIAL instead of the del sign, because you don't want to have to go into equation editor to write in a del sign. I'm okay with that too. Does that make sense? As long as you're communicating what you're doing, I'm happy with that. So you want to practice for this test by typing, because this is a typed test. And again, there's not much I can do about that. because if we're using Factorial, you don't get to have more than one screen going at once. Does that make sense? Okay, because some of you, that won't be a problem because you've been doing your quizzes that way, but there's others of you that have been relying on emailing me or posting some materials on as a picture, but you're not allowed to use your smartphone to take a picture. You see that? So that's just a big note in terms of, rules of the exam. Okay, so type is the big deal, and communicate by typing. Any questions on that? Okay, the content, it should not be too unexpected, but I will tell you, and let me share my screen again, now that we did our vote. So it's not like there's anything strange that you've never seen on this test, but if you look at the syllabus, there's been a lot of sections. We've covered a whole bunch, right? This is what, 4, and then 7 is 11, and then another 8 is, so we covered 19 sections. And each section has a bunch of little pieces of content. So that's going to be one of the hard parts about this, is studying all the different pieces of content and remembering it all. So let me kind of go through the syllabus one piece at a time on things that you should remember. So parametric equations, what kind of things have we done with parametric equations? Pre-calculus parametric equations. I don't see you all jumping in. I know it's been a long time, but you are responsible for the test.
The only thing I can
Between-
think of is, yeah, graphing, like Victor just said.
Okay, so let me tell you something. There's no graphing problems on this test. How come?
You can't make it work with
Yeah,
the quiz function.
Yeah,
in
there's
Canvas.
no way.
Yeah, I don't know how to do it. That just tore me. It's like, man, I want you to be able to graph, but I just can't do it. I can't figure out a way to get you to graph on campus. Does that make sense? So let me tell, maybe I should tell you some things because y'all jump to graphing. You should be able to take a parametric equation and turn it into a regular equation. You should be able to do the opposite. If I give you, I don't know, if I say, what is the parametric equations of, the ellipse, x squared over 4 plus y squared over 9 equals 1, you should know how to write that as parametric equations. Okay, remember how to do those? Remember doing those? So definitely you should know how to do that. Those are the main things you did parametric equations, is convert back and forth. Then we did calculus of parametric curves. And that's probably easier for you to come up with. What should you be able to find?
Derivatives.
Yeah, derivatives. And I'll let you know first and second derivatives. Okay, I could ask either of those. I could ask you to find the max or min, which is basically finding the derivative. Okay, is that clear? Okay, polar coordinates. The main thing about this is that there are some formulas you got to remember. What are the main formulas? There's kind of 3.
Spherical.
No, polar coordinates.
Oh.
We'll get to spherical in a bit. Yeah, x equals r cosine theta. There's 2 more.
Y equals R sine theta.
Yep. And what's the third one? Very important. Kind of comes from these 2.
X squared plus y squared equals r.
Close. X squared plus y squared equals r squared.
Oh yeah, sorry.
That's important. The square is real important, by the way. Okay. So those are the important. Those are important for polar coordinates, and you should be able to, same idea. Write down polar coordinate equations. Equations in polar coordinates given regular, and vice versa. Area and arc length formulas. There were some formulas on those. There's a lot of formulas for this test. Remember the formula? Who remembers the formula of area given a function r equals r of theta? Can you remember it? It's been a while. Yeah. So it's 1/2 the integral of r squared d theta. Okay, so definitely know that. And arc length is, remember that was an integral of the square root. Do you remember that? Of a 1 plus r squared d theta.
Yeah, it was like the curve length formula, right, from last quarter.
Yeah, but for polar coordinates.
Yeah.
Okay. And then there were vectors in the plane. So there's not too much on just vectors in the plane. Really, that's to get ready for everything else. Is that clear? So there's a lot in vectors, but this section itself, I don't think I'd give a question just from this section because there's not much to give. Okay, because I can't make you draw anything. There were some drawing ones, but there's not much to give. Okay, vectors in 3 dimensions, you should understand what those are. That those have 3 coordinates. And unfortunately, what I would normally do, I can't do, and that is make you draw one because it doesn't really work on this test. So that's the one thing you can feel good about or bad, or either way, is you're not going to be responsible for drawing a 3-dimensional vector. Okay, but you are responsible for knowing the dot product. And there are some key equations, key formulas for the dot product. What are the key formulas? Who remembers? Okay, the first is just the definition, and that's the dot product of V and W is a summation of VI WI. So it's either V1, it's either V1 W1 plus V2 W2, or if there's 3 dimensions, it could be V1 W1 plus V2 W2 plus V3 W2. And then there's the second one, good, and Victor's got it, and that is V dot W is equal to the magnitude of V times the magnitude of W times the cosine of the angle between them. Okay, and vice versa, the angle between them is equal to the dot product divided, the inverse cosine of the dot product divided by the product of the magnitudes. Okay, so again, there's a lot of formulas. Okay, cross product. And by the way, how do you tell if 2 vectors are orthogonal?
The angle between them is 90 degrees.
No,
Not
the
90
angle
degrees,
between
pi is-
them is 90 degrees, will not give you orthogonal vectors. Because that just tells you that you were outside maybe in a summer day and you looked at the angle and it's warm. Just a warning. Okay. So first thing is don't ever say the word degree on this test. Got it? Okay, yeah, that's the answer. Dot product is equal to 0. So they're orthogonal, perpendicular, whatever word you want to use, if the dot product of the 2 vectors is equal to 0. That's really important. Okay, cross product. So the cross product, the main formula, there's a formula similar to the dot product, and that is that V cross W is equal to the magnitude of V times the magnitude of W times the, who remembers? Times the sine of the angle between them. Good. Just let you know, if you need to find the angle between vectors, use the dot, not the cross. How come?
Because if you cross product, you get a whole different vector.
No, actually, you'll get the same answer. You get the right answer either
Cross
way.
product is harder.
Yeah, cross product is a whole lot harder. So use it, if you have to find the angle, use the dot product. Got it? Because it's so much easier. Okay, but there are some things you need to know about the cross product. One is that if you take the cross product, you get a new vector, not a number. What can you say about that vector? How does it relate to the other 2 vectors?
It's orthogonal, right?
Yeah, it's orthogonal to both of the other 2 vectors. Okay, so that's one thing. It's orthogonal to both of the other 2 vectors. So Then you got to remember how to take a cross product, and remember there was a matrix and a determinant to do that. So again, I'm going to let you practice those, but I want to kind of review each of the things. There's a lot of different pieces. Okay, then there are equations of lines and planes in space. And just remember that if you have a line in space, those are parametric equations. Okay, it won't just be one equation for a line. That doesn't work for when you're in space. But for planes, it's one equation. Got it? In terms of this section, I wouldn't ask you a direct problem just from this section. How come?
Can you repeat the question? You cut out a little bit.
So I wouldn't ask you a question just from this section that solely relies on this section.
I'm thinking it's because we pretty much did the same thing later on.
Yeah, right here. Tangent planes. Okay, so you have to understand equations of lines and planes. But if I were to ask a question on it, it would be in the context of tangent planes. Because that was like the whole point of doing this. So just let you know, in terms of studying, it's the tangent planes that's more important than just the basics of planes. But if you don't know what a plane is, that's going to be a problem because you won't be able to do a tangent plane. Okay, quadric surfaces. Okay, as I noted, I'm not going to ask you to graph one. But what could I ask you for quadric surfaces?
What is this shape?
Yeah, I could say, what is the shape? Yeah, I could give you an equation, and I can say, what, name it. I could give you a name, and I could say, what, give me an equation that has this. Does that make sense? So those are the kind of things I can give you with quadric surfaces, because I can't ask you to graph, which is too bad, but I can't do that. Okay. Cylindrical and spherical coordinates. So first thing, cylindrical coordinates are the same as polar, except that you also have z equals z. And if you can't remember z equals z, then I don't know. That's such an easy one. Okay, spherical coordinates, on the other hand, they have some equations, and you have to know how to use those equations and know what they are. So if you remember, x was equal to rho times the sine of phi times the cosine theta. Y is equal to rho times sine phi times the sine of theta. And z was rho times the cosine of phi. And x squared plus y squared plus z squared is rho squared. So again, there were some equations to know for spherical. You should know how to kind of work with them. You should know how to go from one to another. So if I give you an equation in spherical, you should go to cylindrical. You should know how to go to cylindrical, and also know how to go to rectangular and any combination thereof. Okay. Any questions on that? Now, I also know how to, and this will come up later, but I want to mention it. You should also know how to deal with derivatives, which I'll talk to in a bit, 3 sections from now. Okay, functions of several variables. This is another one where there's not much to ask you just from this section, because the whole point of this function of several variables is to get you ready for the next bunch of sections, the rest of the course. Okay, so that's no big deal. Limits and continuity. Okay, what could I ask you?
Find this limit.
Okay, so
Or
one thing I
to
could
see if
ask
it
you is
exists.
find the limit. What else could I ask you to do?
Determine if the function is continuous using limits.
Yeah, I'm going to say it a little differently. Determine if the function is continuous, but not just using limits, because that's not enough. I'm going to say using the definition. So remember, the definition is the limit exists, and if you plug that number into the that point into the function, you get the limit. Do you see that? So limits are part of it, but also you have to be able to plug in which is not hard, by the way. Plugging in is easy. So you should know how to do that. You should also know how to prove a limit does not exist and prove a limit does exist. Okay. What I will not ask you is anything with epsilon delta proofs. So don't worry about the epsilon delta. So if you remember, the way you prove a limit exists, our way, is what? Who remembers? Without having to do epsilon delta, there was a nice way of proving a limit exists. Starts with that P.
You can plug in. You can try that first.
That actually doesn't prove it exists. Polar coordinates, remember that? So polar coordinates will help you prove a limit exists. To prove a limit does not exist, what do you do? Who remembers? I know it's been a little while. It hasn't been that long. It's only 2 weeks ago. Yeah, we evaluate the limit in different directions. And if we come up with different answers by going 2 different directions, going to that source, the point at which you're taking a limit to, then the limit does not exist. Okay.
Are you going to ask us to just find the limits, or are you going to say prove exist, prove the limit does not exist, or like prove that the limit exists? Or
The answer is you have to, if I ask you to find the limit, it will also say and prove it exists or does not exist. So yes, you do need to know how to prove it. Yeah. So that's just a note. So yeah, you do need to know how to prove it exists and prove it does not exist, if it, you know, whichever one it is. Okay, partial derivatives. That one, I don't think there's much to say about that. That's typically not the hard part of this class, but if you don't know how to do partial derivatives, you can't do any of the other sections anyway. Do you all agree? Okay, you have no chance. It'll go very bad. This whole class will go badly for you. The whole test will go badly for you if you don't know what a partial derivative is. Okay, so you should know how to take a partial derivative. Tangent planes and linear approximations. So remember the tangent plane, and I recommend using the gradient way of doing the tangent plane, even though we didn't learn about gradients until 2 sections later. But remember that the normal vector to the tangent plane is the gradient. Do you remember that? And then you just say the normal, so that means that the gradient dotted with x minus x naught, y minus y naught, z minus z naught, because that's a vector on the plane, is equal to 0. And then plug into it. Okay, and linear approximations just means that get the equation of the tangent plane and then plug in your value of x, y, z, and that'll give you your linear approximation. That's all it is. Any questions on that one? Okay, chain rule, which actually is bad grammar the way it's written in the syllabus. How come?
Because that might imply the chain rule of just a single variable.
Yeah, but even more, it should be the chain rules. Yeah, because there's a lot of chain rules. And you have to know, it's not memorizing all the chain rules, it's understanding the chain rule. Okay, and how, depending on whether you have, 2 variables going to 3 variables, going back to 2 variables, or maybe 1 variable go to 2 variables, go to 2 variables, whatever it might be, you need to be able to get a chain rule out of it. You should be able to do a chain rule with different coordinate systems. That's a typical way of doing chain rules, or some kind of function given. Okay, so practice a chain rule. Okay, and I will tell you there will be a chain rule problem in the test. I couldn't live with myself if there wasn't a chain rule problem. That's a guaranteed. And the gradient also will occur more than once on this test because it's used a lot. So directional derivatives and the gradient. So remember, what's the formula for the directional derivative, the easy formula that doesn't involve limits? Can you remember? This hasn't been very long. It's only been a few days.
Is it like the gradient times a vector that's in the direction of the direction that you want to go in? That sounds
your idea is right, but I want to refine it a bit. It's first thing, it's not times, it's dot, because you don't times vectors, you dot vectors, right? So it's a gradient dotted with a unit vector in the direction of the vector you're trying to find, in that direction. Okay, so it's a formula. And again, there's a lot of formulas in this stuff. Okay, but if you understand the formula, it's not very hard. So that's how you find directional derivative. The gradient is, hopefully you know how to do that, since we've done it a bunch now. And that is, it's just a list, the vector of partial derivatives in alphabetical order. That's all it is. But it's important to understand what it's used for and what it means. So one thing is that, what do you know about the gradient and level curves?
Gradient is a level curve, correct?
Definitely not. The gradient's a vector and a curve is a curve. And the gradient does not even go in the direction of the level curve.
The gradient vector is tangential to a level curve? It's something like that, right?
Something like it, but that's not right. The gradient is orthogonal to the level curve. It's perpendicular to the level curve. Do you remember that? Okay, on the other hand, if you're in the direction of the level curve, what is the direction derivative? Who remembers? Very easy.
Perpendicular, right?
I'm looking for a number. Directional derivatives are numbers. And so it's very easy. 0, yeah. So the directional derivative is always 0 if it's in the direction of a level curve. And it's always maximal if it's in the direction of the gradient. And minimal if it's the opposite direction of the gradient. Okay? So again, you should understand all that stuff. Okay, max-min problems. How do you find the max/min of a function of two or three variables?
Find the gradient.
Yep, find the gradient and?
The constraint.
But what about, no, the constraint is the next section. We're still in max-mins. We're not in Lagrange multipliers yet. What do we do with the gradient? Yeah, we set the gradient equal to, and notice it's the 0 vector, not the 0 number. So we set the gradient equal to the 0 vector, which means you set each component of the gradient equal to 0. Okay, and then solve. And then you got to do more. Then you got to use a second derivative test. And that was the determinant of the Hessian. If that is positive and fxx is positive, it's a minimum. If it's positive and fxx is negative, it's a maximum. And if it's negative, then it is a saddle point. And if it's 0, you know nothing. So that was the main thing for max and min problems. Any questions on that? Okay, and then Lagrange multipliers, well, we just had a quiz on it. And hopefully you all get that because we just talked about it. So let me ask you, what's probably the best way to study for this test?
Looking back at our quizzes?
Yeah, redo all your quizzes. Because the quizzes are the first thing I wrote all those problems. Okay, so that's a really important thing, is make sure that you can do all the quizzes. Got it? And what I did is I opened them all up, everything except for the one you just took, and that one will open up after I grade it, and that'll be today. But all the other ones are open up, so you can go do it, and don't just do it on paper. Practice typing it out in the quiz, because you don't want the exam to be the first time you're doing some format. So make sure that you do it like the exam. Does that make sense? The other thing you might want to do, because I will tell you, because it's kind of my signature, there are true falses. So you might want to practice some of the true falses that came from the homeworks. That's probably a good idea.
So I understand that, like at least on our last quarter and previous exams we've taken in class, I mean, you would grade by steps
Yes.
pretty heavily. I'm just worried about the time and showing steps online. You know.
Right. So one thing is I'm giving you 2 hours. I'm giving you a little longer time.
Mm-hmm.
And that's important. And more important, see, if you don't show a step, if you show no steps, that's bad. If you miss one step, I won't take any points off. But the problem is if you get the problem wrong and you don't show steps, I can't give you points. Do you see what I mean?
Yeah.
And there's so many little details on this stuff. It's very hard to get anything perfect. And if all you do is you make some little silly arithmetic error, I'm going to give you 9 out of, I'll give you 9 out of 10 on them. Does that make sense? And that's an A. If all you have is an arithmetic mistake, I'm hardly going to dock you at all. Does that make sense?
Yeah.
So that's why you want to show steps, so that I can look at it and give you points.
Okay.
Does that make sense?
Yeah.
But don't like show so much that you don't have time to finish the test either. So it's a balance, and you'll have to decide how that balance works.
Find the middle ground. You got it.
Yeah, and it's do your best is what I can tell you. And again, this is all new. I guess we haven't gone through this since the early 1900s, and none of us were around. Okay, even my grandparents weren't around. So this is new, and hopefully it doesn't last too long. Okay, so the question is, what should you spend time on and what shouldn't? So one thing I did tell you that you're not going to have to do any graphing, because that is something that I can't test you on. So that's one thing. I don't think there's any specific section that's necessarily like out of here, because there's a lot that are combos. Because some of this stuff you need to be able to do the later stuff. Some of the early stuff you need to do the later stuff. So I think pretty much all of this is in the test, but there's combo problems. So for example, if you don't know how to do a partial derivative, you can't do anything else from the rest of chapter 4. So I'm not just going to say, find the partial derivative. But if you don't know how to find a partial derivative, and I give you a problem that involves max and min problems, then you won't be able to do well on the test. You see that? So everything in here is covered, but not necessarily its own problem. Does that make sense? So I was able to get, 12 problems where I was able to cover all the main points. Okay, does that make some sense, hopefully? Okay, so for example, like the dot product, well, if you don't know how to do a dot product, you're not going to be able to find a directional derivative. Do you see that? So this class up till now completely builds on itself. And I want to let you know, we come to a screeching halt after the final exam, after this exam, and we start the class over again. Nothing here is going to come up back again at all in the whole rest of the class until the final. So one thing is, you might want to practice once in a while so you don't completely forget it, because it comes back on the final exam. But at least up until now, we've been building. Okay, you have to understand what a vector is to be able to understand what the gradient is. Okay, so all this stuff builds on itself. So that's why I'm able to do 12 problems and kind of cover everything.
Will we still be doing partial derivatives in the class?
No. except for the final exam. No, partial derivatives are good. Nothing here. Nothing. No vectors, no cross products, no partial derivatives, none of this stuff. I mean, you name it, no quadratic surfaces, any of this. None of this happens again after today. Okay.
Is there going to be a curve?
The way I curve it, and this is why you do the extra credit, is I let the extra credit balance it a little bit. Okay, and you hope that you do the extra credit and you get no points, because you know what that means, right? Which almost never happens, but
You already got 100%.
yeah, it means you got 100%, and then you better smile. Okay, that on this test, it's really hard to get 100% because there are so many pieces of algebra and quick little things that you can make mistakes on. Where you get a 98% instead, which you should still smile, by the way. Okay, but then I can give the extra 2% from the extra credit. So that's kind of a curve-ish way of doing it. Any other questions about the test? I want to mention something, and some of you can tell me yes, and that is the tutors are there to help you out, and they're bored out of their minds because very few people are going to be using them. Okay, we had a little meeting about the Math Club, and that's what they were saying. So go get help from the tutors in Cranium Cafe, and I can almost guarantee that they're not going to be working with someone else, and you're not going to be able to, get help from them because they're too busy, because the tutors are not being used much. So use the tutors. Okay, you can ask me questions too, and I can help. But I am teaching statistics, and I'll be doing that tomorrow all afternoon. But I am, I'm offline. But the tutors are around all day long and can help you out, and most of them know calculus. Any questions at all on anything about this test?
Yeah, I have a whiteboard behind me. Is it okay if I use that instead of scratch paper, or will Proctorio flag me?
The problem is I think you have to get up to use a whiteboard.
Okay.
And you're supposed to sit in the same place. So Proctorio is going to flag you if you move. Does that make sense?
What if
Just
I
like
turn around in my chair? Because it's like at my waist level, so I can use it basically. If I just
think
turn
it
around
might
in my
flag
chair.
you. I think it might flag you because it can't see your face anymore.
Okay.
So it makes sure it's you there. That's the thing. That's one of the things Proctorio does, is it makes sure that it's you looking at the computer the whole time. Does that make sense?
That sucks. Okay.
So paper's fine. You can get paper. You have paper at home, right?
Yeah.
Yeah, use paper. Yeah, get lots of paper. Okay, but make sure you type in the computer. Don't just assume if you wrote it on paper that's enough. It has to be in the computer.
Since we're able to use paper, will we be able to use, say, TI-89 or like
No.
other calculator?
No. No, but I'll let you know I did this test. Like I said, I've taken this test. There's nothing in there that you would need any kind of calculator for. Okay? There's not even any like miserable arithmetic. Let me double check. Yeah, there's not even any hard arithmetic. And you might have to multiply 2 times 3, but I hope you don't need a calculator for that. There's nothing brutal. And I'm not going to ask you to do any simplification. Does that make sense?
Yeah, and
so don't simplify. Don't waste your time on that because
Yeah.
it's a long test.
yeah, and same. I'm guessing with like square roots and stuff, like say an answer.
Yeah, just leave it
You
as.
can
And
leave
if you
it,
want to
yeah.
write SQRT, that's fine, or caret 0.5, however you want to write square root, leave it. Does that make sense?
Yeah.
Yeah. And even the setting equal to 0 and solving, there's nothing brutal. Okay. So there's no like brutal algebra. You might have to factor x squared minus x or something, which means pull out an x. But there's nothing that tough. What's hard is there's a lot of little topics. That's what's hard. It's keeping track of all the topics, because that's kind of what this first part of the class did, is it had lots of topics, this first half. Okay, yeah, so no calculators allowed. I think I do have one that sits in the Proctorio, but I didn't need it, and I didn't do anything fancy. I didn't use any of my like weird abilities. I just did basics. Okay, any other questions? Let me stop the share because we're and stop the recording. 'Cause
On
we're
some
top
of the
hours.
homeworks, it doesn't necessarily ask us